Good morning, girls. Children, we are doing chapter quadrilaterals, and yesterday also I had explained you some theorems. Today again we take up two more theorems. The first one is the diagonals of the parallelogram bisect each other. Okay, now do you remember what I did yesterday? In yesterday's theorem, I had explained you that in a parallelogram opposite angles are equal, and then the other theorem was the converse of the one which I just now told you, that if in a quadrilateral opposite angles are equal, then it is a parallelogram. So go through my video and then check out the proof of the theorems. Now today we are going to study the diagonals of the parallelogram bisect each other. Okay, for that we have to draw a figure, and this is a parallelogram. We take it as ABCD. Yes, and we write what is given. Now it is given that a parallelogram ABCD. Now it is saying diagonals of the parallelogram bisect each other. So we have to draw two diagonals and let them meet at O. So we write AC and BD meet at O. Now to prove that the diagonals bisect each other, we have to prove actually what? That OA is equal to OC and OB is equal to OD, right? Now, to prove this, children, we have to prove that these two triangles are congruent. Fine. Now, to prove that the two triangles are congruent, we have to take out either SAS or SSS or ASA property, right? So, let us check out which one we can apply here. So what did I say? To prove that these two paths are equal, we have to prove that these two triangles are congruent. So let's start with the proof. Now you know that since this is a parallelogram, AB is parallel to CD. AB is parallel to CD and AC is what? It is a transversal. Yes? Now this is a transversal. So let us take this angle. These lines are parallel. When I take this angle and this angle, you can see that these are two alternate interior angles and they are equal. So therefore we can write, and why they are equal? Because the lines are parallel. So we can write angle DCA. Angle DCA is equal to angle BAC. Angle BAC. Okay. Repeat. DCA is equal to BAC. Which angles? Alternate interior angles are equal as the lines are parallel. Now in place of DCA, I can write DCO. I can also write DCO, and for this one BAC, I can write it as BAO. Okay, so this is one part. Fine. Now I hope you can see. Now coming to the next side, again AB is parallel to CD. Again, we know that it is a parallelogram, and BD is the transversal. Now when BD is a transversal, which two angles will we consider? This angle and this angle. So we can again write that CDB, angle CDB is equal to ABD, angle ABD. Yes, now I can also change the name and write for CDB. For CDB, I can only write CDO. So CDO is equal to what? ABO. Now we have got two angles to be equal, and what angles are these? Alternate interior angles are equal as the lines are parallel. Now we will consider these two triangles. As I told you that we will prove them to be congruent. Now in triangle AOB and triangle COD, now we will choose the three parts and then we will take out the congruence condition. In the triangle AOB, see, AOB, we know that BAO is equal to DCO, and where we have proved, we can write proved above or proved before. Second part, in the two triangles we have also proved that CDO is equal to ABO. So we can write angle ABO is equal to angle CDO. Again we can write proved above. Third part. In the third part we can write AB is equal to CD and why? Opposite sides of a parallelogram are equal. We know this property. Now therefore triangle. These two angles and the side, these two angles and the side, which property is this? This is ASA. So triangle AOB is congruent to triangle COD by ASA property or ASA congruence. Now when the two triangles are equal, you know the corresponding parts are equal. So therefore we can write hence OA is equal to OC and OB is equal to OD, and what is the reason? CP CT. So therefore in the end we can write that the diagonals of the parallelogram bisect each other. Okay, so you can understand the proof, draw the figure, see what is given, write what we have to prove, and then start with the proof that AB is parallel to CD with this as a transversal, C as a transversal, then AB is parallel to CD with BD as a transversal, and then take alternate interior angles to be equal. And why we are doing this? That first we are going to prove the two triangles to be congruent, and then we'll take AO is equal to OC and OB is equal to OD as the corresponding parts of the congruent triangles. Okay, so I am completing this now. I am finishing this, and we now come to the next one, that is the converse of this. Okay, children, practice these theorems nicely, and then only you will understand how to start with the proof of any theorem. Now coming to the next one, it says that if the diagonal of the quadrilateral bisect each other, that is a converse. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Okay, so the figure which we are going to draw here is not the parallelogram, but it is a quadrilateral. Okay, so let's start. Same type of proof. A, B, C, D. Now we'll see what is given. Quadrilateral ABCD. Yes. And what next? These diagonals meet at O. So AC and BD meet at O. Now the statement says that the diagonal of the quadrilateral bisect each other. So it is given that OA is equal to OC. Yes. And what? OB is equal to OD. This is given to you, and to prove that ABCD is a parallelogram. To prove that it is a parallelogram, we have to prove that these sides are parallel. Yes, children. So let us start with the proof, and let us consider the same triangles which we have taken in the previous one. We can also take these two, we can also take these two. So let's start with AOD. Okay, triangle AOD and triangle, which one? BOC. Now, what is given? We have to prove them to be congruent. We will write first. This is a quadrilateral. Okay, so we have AOD, yes, and BOC. Okay, now we know that these angles are equal. So we write angle AOD is equal to angle BOC. Vertically opposite angles are equal. Now we know that OA. Can you see? OA is equal to OC. Second point given. Okay. OA is equal to OC, and the third part will be OD is equal to OB. Now as you can see that we have two sides and one angle, so we will write triangle AOD is congruent to triangle which one? BOC. Yes. And when the two triangles are congruent, by which congruence over here? We have one angle and two sides, so we have SAS property or SAS criteria. Okay, now looking at these two triangles, we have taken AOD. Now when the two triangles are congruent, you know that the corresponding parts are equal, so we can write or we can mark this angle, right, is equal to which angle? This one. So therefore angle ADO, yes, is equal to angle wait, sorry, which one? This, okay, no, in ADO, yes, correct. And with this angle we have to take this one. Okay, so I will write ADO is equal to CBO. Yes. Now what type of angles are these? These are alternate interior angles. And why, children, these angles are equal? Because of the congruent parts of the congruent triangles. Now since these two angles are alternate interior angles and since they are equal, therefore we can write AD is parallel to BC. Okay, did you follow? Now we have proved one part. As I told you that to prove that this is a parallelogram, we have to prove the opposite sides to be parallel. Now similarly we can prove that AB is parallel to CD by considering another set of triangles, and which one? AOB and COD. AOB and COD. So same type of proof you will do, and then in the end you will prove that AB is parallel to CD. Now since AD is parallel to BC and AB is also parallel to CD, therefore ABCD is a what? A parallelogram, because opposite sides are parallel to each other. So then in the end we can write that if the diagonals of the quadrilateral bisect each other, then it is a parallelogram. So how will you do? You will draw the figure, you will draw the quadrilateral, yes, and then you will prove the two triangles to be congruent by SAS. And when the two triangles are congruent, these two angles are what? Alternate interior angles. By CPCT they are equal, and when these alternate interior angles are equal, these sides are parallel. Similarly, in the second part, you can directly write that similarly AB is parallel to CD, and you can try out the proof yourself taking these two triangles to be congruent, and then AB is parallel to CD, AD is parallel to BC. Hence, since the opposite sides of the quadrilateral are parallel, therefore ABCD is a parallelogram. And then in the end you can write, since the diagonals of the quadrilateral bisect each other, it is a parallelogram. So children, you practice these two proofs in your notebook. If you have any queries or any doubts, you can ask me. Okay, and complete all your previous work also. Thank you. Have a good day.